Hello. So let us start the assignment number 3 here. So this is spread spectrum communication and jamming. So the assignment is write a MATLAB code to generate small set Kasami codes with length 15. Next is check its periodic autocorrelation and cross correlation properties. There's some special note here. Periodic autocorrelation and cross correlation functions are defined as first the autocorrelation function. This is m equal to 0 to m minus 1 ci m and ci m plus m. And the cross correlation is m equal to 0 to m minus 1 m cj m plus p new. Okay. So what are these coefficients? CIM denotes image sample of ith Kasami code with length m. It should be noted that Ci m plus nu is equal to Ci m if remainder of m plus nu in big M equal to n, where what is this REM function? X and y is the remainder of the division of x by y. Okay, so the hint about this problem is periodic cross correlation between any two small set Kasami codes can take the values -1, minus 2 to the power n by 2 plus 1 and 2 to the power n by 2 minus 1, where n is equal to log 2 m plus 1. So the hint is periodic cross correlation between any two small set Kasami codes can take the values. First value is -1, second is minus 2 to the power n by 2 plus 1, another is 2 to the power n by 2 minus 1, where n is what? Log 2 m plus 1, and m is the length of the Kasami code. Okay, so the question is about to write a MATLAB code to generate small set Kasami codes with length 15. So m is equal to 15, and then we have to check the periodic autocorrelation and cross correlation properties. So just before beginning the code, we'll just discuss about the Kasami codes a little bit. That is, the most important property of Kasami codes is that the peak value of the cross correlation functions are even smaller than for the gold codes. So for gold codes, phi of max decreases as square root of 1 by root m for large m. M is the length of the sequence. So these Kasami codes are also derived from M sequences, M number of shift register, I can think of that. So the degree M of the corresponding polynomial has to be even. Degree M of the corresponding polynomial has to be even. And if it is the case, then the length m is equal to 2 to the power m minus 1, and this m can be factorized as m is equal to 2 to the power k minus 1 to the power k plus 1, where k is equal to m by 2. So starting from a m sequence, so we start from a m sequence. We define it as C0. The corresponding decimated sequence CD is obtained by a relationship, and that relationship is take every dth chip from C0 where d is equal to 2 to the power k plus 1 for a Kasami code generation. And then repeating these 2 to the power k minus 1 chips, how many times? These 2 to the power k plus 1 number of times. Now the resulting code sequence CD has the same length as C0, but a period of 2 to the power k minus 1. So whatever code sequence that CD comes from here has the same length as C0 but has a period of 2 to the power k minus 1. Then the set of Kasami codes is constructed as by taking C0 and the modulo 2 sum of C0. And all 2 to the power k minus 1 cyclically shifted versions of CD. So basically, if we compare gold code and Kasami codes of length m, the peak value of cross correlation is lower for Kasami codes. Whereas the cross correlation functions of gold codes take the lowest possible value of minus 1 by m more often. Okay, so the main 4 steps are take every dth chip from C0 first, starting from a M sequence C0, and then take every dth chip from C0 where d is equal to the power k plus 1 for a Kasami code generation, and repeating this to the power k minus 1 chips. How many times? This many times. Why? Because this can be factorized as a form of this. So this many number of chips can be repeated this many number times. So repeating this to the power k minus 1 chips this many times, and the resulting code sequence CD has the same length as C0 but has a period of to the power k minus 1. This has a period of to the power k minus 1. And then the set of Kasami code is constructed by taking C0 and the modulo 2 sum of C0 and all to the power k minus 1 cyclically shifted versions of CD. So this is constructed by taking C0 modulo 2 sum of C0 and all to the power k minus 1 cyclically shifted versions of CD. Okay. What is the advantage? The peak value of cross correlation is lower for Kasami codes, whereas the cross correlation function of gold codes take the lowest possible value 1 minus m mod of m. That is the advantage, that is disadvantage. So let us go to the MATLAB. Write this function. So first we write so this code is to generate Kasami codes. Then what is the another objective is to check the cross relation properties. So first let us start it. So first generation of the M sequence for M is equal to 4. Where M is equal to 4. So the normal MATLAB functions here, you will see here are close all. So what is M here? Let us define the variable M is equal to 4. Why? Because let us show it here, 2 to the power M minus 1 अनुल्ला अनुल्ला एक बार आएगा। यस यस आना।
मैं देखो पेनड्राइव को कैसे बनाने का है।
टू टू दी पावर हाउ टू राइट टू टू दी पावर क्या क्या ओके 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 ठीक है समझ गया। So this is to the power m. M is here 4 minus okay. This is 15. So that is what m was. M was equal to 15, right? Okay. So m is equal to 4 here, and then g is equal to 1 0 0 1 1. This is what? This is the generator polynomial that corresponds to x to the power 4, and this x and this is 1. So this is x to the power 4 plus x plus 1. G is the generator polynomial. And C is equal to the initial state of the shift register is C. This is 0 0 1 1. This is initial state of the shift register. So let us show these two arrays are defined by these three values. Let's run this thing. And this is the G, and this is the C. And now let us define the length of the shift register, that is 2 to the power m. M is the M sequence, so how many number of shift registers are there? Minus 1. Let us define the maximum sequence, output sequence of the shift register, that is the maximum sequence. This maximum sequence is, just keep in a blank right now, and this is, define it, output of the shift registers. Now this was mentioned that take every DH chip from C0 where D is equal to the power k plus 1 for a Kasami code generation, and repeating this to the power k minus 1 chips at 2 to the power k plus 1 times. Okay. So just write a for loop for this. For II is equal to 1 to length is to the power m minus 1, that is 15 for all the 15 sequence. How do I do it? The max sequence is equal to this max sequence, let us small equal to max sequence and the first element, right? Because I have to take C0 and all the values based on this information. DH chip from C0, and then the length of the code sequence CD has a length of C0, and how the codes are generated, because taking C0 and all these things. So start it. Now let us define a temporary variable of ctemp, that is XOR of the sequence G1 into C1. I have to do the XOR operation there, and the image sequence into C of M. So at each state of the shift register is like this, first for the first few things, and then we just do it based on this. So basically doing the XOR operation on all the bits. And then take the first m minus 1 elements, and this is equal to C of 2 to m, and then C of m, the mth element of the C is equal to, for every loop that is I is equal to 1 to length, there are 15 number of times this loop will run, and for each of them this total C will change depending on the values we are providing. C 10 is ended. So what this loop does update the shift register. So for the first I is equal to 1, this is null and it is taking the first input of this, then doing the XOR operation on both of them, and then it is taking 1 to m minus 1 values. The first, for this case, the first 3 values as the last 3 values, and then it is placing the fourth value here as ctemp calculated from this loop. So that is the logic here. And then we define max length sequence is equal to a double. This is logical to double. Okay. Now as we mentioned here, k is equal to m by 2. K is equal to m by 2. Degree m of the corresponding polynomial has to be even. At that case, k is equal to m by 2. So let us put the value k is equal to m by 2. And what is the value of d? D is equal to how many number of times that will be repeated in this sense, as we mentioned here. Sorry, this is 2 to the power k plus 1. 2 to the power k plus 1. So k is the m sequence m by 2 for m is even, and then d is equal to 2 to the power k plus 1, right? So now write this pattern following this method. Okay. Repeating 2 to the power k minus 1 chips 2 to the power k plus 1 times, and every time take the dth chip from C0. So pattern temp equal to max length sequence. The max length sequence is the double of the logical double here, and a dth chip from here. Next, for the next thing, 2d. Now I have to take that 2 into d, and then I have to take 3 into d. So this is here, it is written as we explained earlier. It has to be repeated to the power k plus 1 number of times, and repeating that to the power k minus 1 chips. So there are to the power k is equal to n minus 1 chips, and so basically the first 3, and this is the pattern has been generated here. Now the temporary sequence is equal to the chronic. This is the it's 1 comma d. Pattern temporary. So basically it does a sort of matrix multiplication, but it does the tensor product multiplication. like it takes the first value of each of them and then multiplies with the each of the patterns. Every one is getting multiplied by the pattern temporarily, whatever has been generated here, and they are stored as a matrix there. So this is defined from matrix multiplication process, but it is a tensor product multiplication. You can search it in Google. So why I have generated this? This has been generated due because I have to do repetition of the pattern as discussed earlier in the text. I have to repeat that to the power k plus 1 number of times, and d is to the power k plus 1. So that many numbers of times I am generating the same pattern here. And this was pattern generation. Let me specify it. This is how we generated the pattern, actual pattern. Every dth element we have taken. And k is equal to m by 2, so that is 4 by 2, that is 2, and 2 to the power k minus 1, that is 4 minus 1, that is 3. So according to this logic, let me repeat it, we are repeating 2 to the power k minus 1 number, so that means 3 chips at 5 number of times here. And then first Kasami sequence that is stored temporarily just with a variable equal to the XOR of max length sequence and temporary sequence. Here we are following this logic, the last logic. The Kasami code are constructed by taking C0, modulo 2 sum of C0 and all the to the power k minus 1 cyclically shifted percents of CD. And then Kasami sequence, let us define another sequence. Kasami sequence first is two into double Kasami sequence one temporary. The same variable is written here, so it is taking, and with that we just, as we doubled it, that's as the modulo operation here, 1 comma length. And this should be minus here. And then the Kasami sequence 2 that we set temporary, the same operation will be repeated for this. Is equal to 2 into, sorry, first thing is the XOR operation between max length sequence and the circularly shifted version of temp sequence. One. this is just taking the transpose. So pattern is generated like this, and the temp sequence is also generated like this. Now we just stop the values just getting printed here again and again, and then Kasami sequence 2 is equal to 2 into double Kasami sequence 2 temporary minus 1 comma length. That is again converting to the logical double. Now, sorry, something is mismatched here. Sorry, the minus sign was not there. This should be a minus. Because this is a XOR operation. Now define autocorrelation as this, and we will store the autocorrelation and cross correlation values in these arrays. And then just define a variable for jj. Just we'll check the we have generated the codes. Now we have to check the cross correlation and autocorrelations. Just 2 sequences we have generated, and that is from minus len to plus 1 to 1 to length minus just end the loop, and inside the loop we have to calculate the cross correlation and autocorrelation function. So the autocorrelation that we will define now is like equal to autocorrelation Kasami sequences. The first sequence 1 into circularly shifted version of the same sequence, Kasami sequence 1 tick comma jj. This should be closed here to say whether it runs or not. Fine. And then we have to calculate the cross correlation function. Just write it auto correlation, not auto cross. And this is equal to the cross correlation values. We'll store those cross correlation values here, and first one is Kasami sequence 2 for this one, Kasami sequence 2 into circularly shifted version Kasami sequence 2. Sorry, this should be for 1, right? We are calculating it. We should not calculate the autocorrelation function. So for the 1, and we are shifting the second sequence here. Safety. Sorry. let us plot it. Figure, and then just define a variable shift index that varies from minus len plus 1 to 1 to len minus 1. This is the x-axis, and then stamp the values of the x-axis first, shift index, and then autocorrelation function. And then we define the x level as shift index as mentioned, and also y level as the autocorrelation function. So just try to plot it. So this is the figure actually. The autocorrelation has a peak at 0. So basically it has a peak at 0, and then it just decreases as we mentioned here. The peak value of cross correlation is lower we have to mention the autocorrelation function. The Kasami goes is peak value of the cross correlation function is even smaller for the gold codes and decreases as 1 by square root of m. So to show this, we have to generate the cross correlation function also. Now let us go for the next figure, which as we have already calculated the cross correlation functions. So this is basically another figure, stem the same shift index, so basically it is shift index here, and then the cross correlation values. And now plot the x level. Mention the x level what is. So x level is shift index. And y level is cross correlation. So let us run this thing once again to show what is the cross correlation comes. But this is basically cross correlation. At 0 this is very negative. However, the autocorrelation has a peak at 0. So the peak value of cross correlation is lower for Kasami codes, whereas the cross correlation function of our gold codes take the lowest possible values. So basically we can see that the peak value of cross correlation is lower for Kasami codes. So the peak value of cross correlations are, see, this is very much lower, -5, than these positive values. The similar fact, the autocorrelation function is higher at shift index at k equal to 0. So following the algorithm we have discussed earlier, take every dth, so starting from m sequence c0 and the corresponding sequence cd decimated sequence is obtained by taking every dth chip from c0 and where d is equal to the power k plus 1, that we have done in this section in this way. And then we have to take every dth chip d, 2d, 3d in this sequence we have taken it, and then repeating this to the power k minus 1 number of chips by to the power k plus 1 times. This has been done by the tensor product function cron in the MATLAB function. Once again, this cron function has done that step, and then the resultant code sequence CD has the same length as C0 but a period of to the power k minus 1. So basically we start from an n sequence and then we get a decimated sequence CD, and that has the same length as C0 because it also comes as the output of the shift register, but it has a period of to the power k minus 1. After that it just repeats. So this generates a periodic sequence, and then we go, the set of Kasami codes is constructed by taking the first element C0 and the modulo 2 sum of C0 and all the to the power k minus 1 cyclically shifted versions of CD. So that is done in this section. This circularly shifted version, here it is generated by circularly shifted function of this and the Maxwell sequence, and this has been generated, and first we are doing the XOR sequence between these two, and then we are just another XOR operation is being done here, and after that we generate two different Kasami sequence 1 and Kasami sequence 2, and then we just calculate the autocorrelation function and cross correlation function between them, and we just plotted them, and we see that autocorrelation function gets a peak at k, shift index at 0, and for 2 the cross correlation function at 0 is very negative. So this was for today.
Sir,
Yes.
aren't the assignments yet being checked because there is no grading being is showing up on our assignment?
uh, uh, just wait a minute, your voice is not clear, I am just taking the headphone, just wait a minute.
Yeah, yeah, yeah. Hello. Sir, am I audible?
uh, yes, you are audible, just wait a minute.
Yeah, I was saying in my progress actually I have submitted the assignment, but no grades are being shown as of now. So
Okay, uh, then you can raise a query there, that will be beneficial, like there are sections, right,
yeah,
in the actual NPTEL site. So I am not basically checking the assignments.
so your voice is very low.
So actually I am not checking the assignments. Is it clear?
Acha, okay, okay.
Okay.
I mean, you don't have any idea whether the assignments have got checked or not, like.
No, I don't have any idea. Like you have any doubt about the coursework and questions, then you can ask me. But this
Acha.
evaluation section, I don't handle that.
Okay, okay. And secondly, actually, then it could be regarding the evaluation only because it was being told to us to do it on MATLAB. But since I had Octaves, which is a freeware available, it was already installed in my system. So I have performed it on Octave, although it is quite similar to MATLAB. And that I have uploaded. So I mean, I wanted to ask about that also. Is that fine?
I think that will be considered. Like they both follows the same sort of codes. Like MATLAB and Octave both follows the same sort of
Yeah,
codes.
yeah, yeah.
So I don't think that will be a problem at that case.
So, what should be the process like? How should I approach what is the status of the assignment? I mean, I haven't yet got any score as such.
The best way spread spectrum and communication and channel. About that NPTEL page has some, I think that fact section or some to raise some question. All these things are there, right?
I need to
There
check.
is a
Or else,
section
okay, is
where
it okay if we shoot a mail back? I think we are getting reminder mails from NPTEL this course. There only we can raise a query.
I think you can try about that, like
Acha.
about this problem setting, or there is a feedback form also that is coming every week.
Yeah, because the next assignment is due and still the previous assignments was not showing up. So I was like a bit confused about that. Whether I thought because I've uploaded it from Octave, so is that the case that nothing? But at least 0 marks to दिखना चाहिए. So something has
Okay,
to be
okay,
there.
okay. That thing, I actually I have no authority to comment about that. Like I don't
Yeah, yeah,
actually
I
know what
understand.
is the things are going there. So
No
basically,
worries,
you
there's
raise
no
the
worries.
question at least to the NPTEL section, or at least in the feedback section of the NPTEL coursework. That will
Fine,
be
sir.
better.
I'll just drop a mail and let's see how it works out.
Yes, yes. Thank you.
Yeah, thank you so much.